My name is Abraham Otieno Mondi. I am a lecturer, Department of Electrical and Electronics Engineering. So today we want to cover equation, the revision equation in Matrix 2, Mathematics 3. The paper is July 2019. If you have not subscribed, the other videos, kindly you can subscribe. You can send this video to many engineering outside. Everyone who is taking engineering course, you can send to them. So let us revise this topic. A matrix, determine the eigenvalues and the corresponding eigenvectors of the matrix. So before I start solving the problem, solution, matrix, we have learned matrix from our year one. We have learned matrix right from primary school, right from secondary school. Now at diploma level, we also learn a matrix. In our year one electrical engineering, we learn the simultaneous equation, elimination equations. We learn 2 by 2 matrix, 3 by 3 matrix. We also learn how to multiply a matrix. But today, we want to go further and discuss some terms known as eigenvalues and eigenvectors. So let us solve this problem. Let us solve this problem now. What is the formula of solving? I'll start with the eigenvalues. The eigenvalue. Because this one is a 10 marks question. Eigenvalues is 5 marks. Eigenvector is also 5 marks. So, if I have the determinant of A minus the lambda multiplied by the unit vector is equal to 0. So this is the formula that we are going to use to get the eigenvalues. Now let's continue. So we have our A, our vector A is here. So we are going to have vector A, 2, 1, 3, 4, by the bracket, and close the bracket because it's a vector, minus the lambda, multiplied by the unit vector. We introduced the unit vector in year 1. So we say that a unit vector is the one with the diagonals as 0, we have 1, 0, 0, 1. And you have just said this sign of the determinant. So you are going to get the determinant of this. All this is equal to what? 0. So, mathematically we have 2, 1, 3, 4, close the bracket, subtract, lambda multiplied by 1, we have the lambda multiplied by 0, it is just 0, lambda multiplied by 0, it is a 0, lambda multiplied by 1, it is our lambda. Very good. Open the brackets. Remember all this, you get their determinant is equal to 0. Good. Now let's subtract this. The same way we subtract matrix in year 1, it is the same way we will subtract matrix in our year 3. So 2 minus lambda. 2 minus lambda, what do we get? We get 2 minus lambda. 1 minus 0 is just 1. 3 minus 0 is just 3. 4 minus lambda is 4 minus lambda. All of these, you get their determinant and your answer must be equal to 0. Your answer must be equal to 0. So, let's get the determinant of this. How do you get determinant in our year 1? And we say we are going to multiply the diagonal, multiply and subtract this other diagonal. So we are going to have the determinant is we have negative, we have 2 lambda multiplied by 4 minus lambda minus this multiplied by this, of course, is just 3. All of this one is equal to what? 0 is equal to 0. Now we get the determinant. We get the determinant of 2 minus lambda 2 minus lambda, 4 minus lambda. So let's multiply this one. We have 2, open the bracket, 4 minus lambda, minus lambda, minus lambda, open the bracket, 4 minus lambda, minus 3 is equal to 0. So 2 multiplied by 4 is 8, minus 2 lambda, minus 4 lambda, plus lambda squared minus 3 is equal to 0. So let's collect the like terms. We have lambda here, lambda squared. We have negative 2 minus 2, so that is negative 6. Negative 6 lambda. We have 8 minus 3, that is plus 5, is equal to 0. So we can use a quadratic formula. We can use a quadratic formula to solve this problem. And the quadratic formula says negative b plus or minus the square root of b squared minus 4ac divided by divided by 2a. We also have this one in our primary and secondary school. So I know no one will have a problem with that. So let's have this part. So, what is the value of net? We have negative b, and our b is here. So, negative and negative will have a positive. Therefore, we have 6 plus or minus the square root of b. So, it is b squared. So, that is negative 6 squared, which is 36. 36 minus 4a. So what is our a? Our a is 1, so we still have 4. So it is 4 multiplied by c, and our c is 5. So it is 4 multiplied by 5, and that is 20. Divide by 2 times 1. 2 times 1. So when we have 6 plus or minus 36 minus 20, what do we get? 36. I think that one is 16, if I'm not wrong. 36 minus 20, this one is 16. So it is 16 square root of 16 divided by 2. This one is equal to 6 plus or minus the square root of 16, that is 4. 4 divided by 2. Now, our eigenvalue for the first value, our eigenvalue, I don't know if our cameraman can see this side, so that we can have our eigenvalues, and then we discuss our eigenvectors. So, the first lambda, 1 is given by 6 plus 4 divided by 2. This one is equal to 10 divided by 2, which is equal to 5. Or number 2 can also be gotten as 6 minus 4 divided by 2. So that is 6 minus 4 is 2 divided by 2, which is equal to 1. So the eigenvalues are 1 is 5 and the second one is 1. So already all this, I think, is only 5 marks we can earn from that one. Now we want to go to the second part of the equation for us to earn the whole marks, for us to get the whole marks, for us to get the whole marks. Now I wrap this part, I clear this part, I clear this part. The good thing with the video, you can pause or you can pause and watch again and watch again. So don't worry. So let's discuss the eigenvectors. So the eigenvectors, we have calculated and get the eigenvalues as the eigenvalue of 1 is equal to 5 and eigenvalue of 2 is equal to 1. And the formula that we are going to use is just the same, a minus the lambda r. The determinant of those two multiplied by x is equal to 0. And there is a place to calculate this calculation where we have a minus lambda, and it's here. In fact, know the determinant, you can just put in the bracket here. So therefore, we have our answer here. That's why I didn't have that position. So that is 2 minus negative lambda. 1, 3, 4 minus lambda. All this multiplied by x is equal to 0. Now, this is our formula. Now, let's solve this one with our first lambda. And for our first lambda, we have calculated the lambda 1 is equal to 5. Now, the simplest thing, you replace any place you have lambda here, we replace with 5. So we are going to have 2 subtract 5, 1, 3, 4 subtract 5. All of this you multiply by x. Now you make this x a matrix in a matrix form. So I'm going to have x1 and x2 is equal to 0. So you also make this 0 a matrix form, which is equal to 0, 0. Wonderful. Now let's use matrix method to multiply this. Before that, let's solve this one. 4 minus this one is just 3, negative 3. So let's just write here negative 3. 4 minus 5 is negative 1. You don't waste time on that, okay? So let's multiply this using a matrix. So I have negative 3 x1 plus x2 is equal to 0. Another one we have 3x1 minus x2 is equal to 0. So let's use any of this equation to get what is x1 and what is x2. Therefore, let's say equation 1, x2 is equal to 3x1. 3x1. So that means my x1 is equal to 1 and my x2 is equal to 3. So to write this eigenvector, it's written like x is equal to 1, 3. So this is your answer for eigenvectors. But this one is for what? The eigenvalue of what? 5. And we have found 2 values. That is 1. So let's do it for the second round. So we can say this one is for 1. Or it's just okay to leave it like that. Now, I will not drop this one, but rather I can clear this other side. I can clear this other side. So for you to understand. Now let's discuss for eigenvector 2, which is 1. So we are going to do this formula again. So we have 2 minus a lambda, 3, 1, 4 minus this one is equal to this one. Now we replace where we have lambda with 1. So automatically I have 2 minus 1. I also have 1 here. This one is 3, this one is 4 minus 1. Make this x in form of a matrix. That is x1 and x2. Also our answer to be in the form of a matrix. Therefore, let's multiply this one. So, before you multiply, you can subtract because it's very easy. So, 2 minus 1 is just 1. And then 4 minus 1 is 3. So, let's do the calculation. This one multiplied by that one is x1 plus x2 is equal to 0. And another one is 3 x1 plus 3x2 is equal to 0. Let's get the value. So, the value here, I can take any. So, x2 is given by negative x1. Therefore, this means x1 is equal to 1 and x2 is equal to negative 1. Therefore, the eigenvector of eigenvalue 1 is equal to 1, negative 1. And this is your answer. So this is just one question, very simple question in matrix year 3. So I will advise you, mostly I advise my students in exam room, kindly start with this question. Kindly start with this question because these are free 10 marks. We have topics like 4-year series, they are very easy, but they will take a lot of time. They will take a lot of time. We have very simple units such as numerical methods, very simple. In the exam room, start with such topics. And this is the one and the most important topic that you need to start with. Thank you very much for watching. You can subscribe, you can like and watch more videos. Thank you.